Welcome to History Unfolded, where we embark on an epic journey through the history of our planet, one event at a time. Today, we start at the very beginning with the formation of Earth, a story that spans billions of years and sets the stage for everything we know today. Section 1. The Solar Nebula. Our story begins about 4.6 billion years ago within a vast cloud of gas and dust known as the Solar Nebula. This cloud, a remnant of a previous generation of stars, was primarily composed of hydrogen and helium, with traces of heavier elements forged in the hearts of ancient supernovae, the explosive deaths of stars that came before our sun. Over time, the delicate balance within this cloud was disturbed, possibly by the shock wave from a nearby supernova. This disturbance caused regions within the nebula to collapse under their own gravity, forming denser clumps of material. At the heart of one of these clumps, temperatures and pressures rose until nuclear fusion ignited, giving birth to our sun, a new star shining brightly in the early universe. In the early days of our solar system, after the sun ignited at its core, a swirling disk of gas and dust was left in its wake, a protoplanetary disk that would become the birthplace of planets. Within this spinning disk, tiny particles began to collide and stick together, a process known as accretion. Over millions of years, these particles grew from mere specks of dust into pebbles, then rocks, and eventually kilometer-sized bodies known as planetesimals. These planetesimals were the building blocks of our planets. Imagine a chaotic cosmic dance where these massive objects collided at high speeds. Some of these collisions were gentle, allowing the planetesimals to merge and grow into larger bodies, while others were catastrophic, shattering them into countless fragments. This violent yet essential process was like a cosmic demolition derby, with each collision reshaping the early solar system. It was within this chaotic environment that the seeds of Earth were sown, setting the stage for the planet we call home today. Every planet, every moon, and every asteroid in our solar system started its journey in this disk, where the foundations of our cosmic neighborhood were laid. Earth's early history was marked by a cataclysmic event that forever shaped its future. Around 4.5 billion years ago, a Mars-sized body known as Theia collided with the young Earth in a cosmic impact of unimaginable scale. The sheer force of this collision was enough to vaporize much of Theia, scattering a vast amount of debris into space. This debris, a mixture of both Theia's and Earth's material, didn't just drift away into the void. Instead, it began to orbit the Earth, gradually coming together to form our moon. The formation of the moon was a pivotal moment in Earth's history. It stabilized the planet's axial tilt, which is crucial for maintaining the seasonal cycles we experience today. The moon also influenced Earth's rotation, gradually slowing it down and giving us the 24-hour day that regulates life on our planet. This monumental impact set the stage for a planet that would become home to diverse ecosystems and eventually to humanity itself. Amid the swirling chaos of the early solar system, a young Earth began to take shape. As planetesimals, those early building blocks of planets, continued to collide and merge, Earth grew larger, evolving into a fiery protoplanet. The relentless energy from these collisions, combined with the heat from radioactive decay deep within, kept Earth's surface in a state of molten fury. Imagine a world where temperatures soared high enough to melt rock, with its surface constantly bombarded by space debris, reshaping the landscape over and over again. This early Earth was nothing like the planet we know today. It was a seething, hostile environment. But within this chaos, something extraordinary was happening. As Earth grew, its materials began to separate based on density. Heavier elements like iron and nickel sank toward the center, creating a dense, metallic core. Meanwhile, lighter elements rose to form the mantle and crust. This process of differentiation was critical. It laid the foundation for the Earth's magnetic field, which protects us from cosmic radiation, and for plate tectonics, which shaped continents and oceans. These developments were essential, setting the stage for a planet that could one day support life. After the moon formed, Earth entered the Hadean Eon, named after Hades, the Greek god of the underworld. This was a time when Earth was anything but welcoming. It was a fiery, chaotic place. The planet was still cooling from its molten beginnings. with a surface covered in oceans of lava and intense volcanic eruptions. The atmosphere was thick with gases like carbon dioxide, methane, and ammonia, not the breathable air we have now. During this era, Earth faced constant bombardment from asteroids and comets, a period called the Late Heavy Bombardment. These impacts were so intense they could vaporize any water on the surface and reshape the planet's crust. Despite these extreme conditions, the Hadean Eon played a crucial role in setting up the environment needed for the future development of life. About 4.5 billion years ago, Earth's story took a dramatic twist. Imagine a Mars-sized planet named Theia crashing into the young Earth in a colossal cosmic collision. This epic impact was so powerful, it vaporized Theia and sent tons of debris flying into space. This space debris, a mix of Theia's and Earth's shattered pieces, started orbiting our planet. Over time, this cosmic rubble came together to form our moon. But the moon wasn't just a cool new neighbor. It changed Earth's future forever. It stabilized Earth's tilt, which means we get the seasons we know today. Plus, it slowed down Earth's rotation, giving us the 24-hour day we live by. This incredible event set the stage for everything that followed on our planet. As Earth started to cool down after its fiery beginning, something amazing began to happen. The once molten surface began to solidify, creating the very first crust. But this wasn't just any crust. It was the foundation for everything that would follow. Volcanic eruptions were intense, releasing water vapor and other gases into the air in a process called degassing. Imagine the skies thick with steam and volcanic fumes as the planet's early atmosphere took shape. Then as the planet continued to cool, the water vapor in the atmosphere began to condense. Picture giant clouds forming and the sky opening up, unleashing torrential rains that lasted for thousands of years, literally raining for centuries. These rains were no ordinary showers. They were the first downpours that filled Earth's basins, forming vast oceans. This was a game changer. Liquid water covered the Earth's surface for the first time, creating oceans that would become the cradle of life.